Hello pre-calc, welcome back. We are going to be looking at transformations of the graphs of secant and cosecant today. I'm going to force a pause on your screen, make sure that you have everything on the checklist ready to go. Alright, I'm going to force another pause on your screen. If you can, you don't need to write these down, but just kind of think about in your head, what are the reciprocals of the function, the numbers shown on the screen. When you're ready, hit continue. Alright, answers are on the screen. Remember, reciprocal means you're just going to flip the numerator and denominator, but do keep the signs. So the reciprocal of -1/5 is -5. Reciprocal of 1 is still just 1. And here's an important one that we're going to be using as well today. The reciprocal of 0 is 1 over 0, which is undefined. One way you can kind of remember it is 0 on top is okay, that's a 0, but 0 on bottom is no, that becomes undefined. Alright, so question for you, which parent function do I have on the screen right now? Sine of x or cosine of x? This is cosine of x. If this is a parent function we're looking at, I can tell that I have the point 0, 1. Cosine of 0 is 1. So remember, cosine kind of starts, if you will, at its maximum. Sine starts at its midline, also known as its equilibrium. Okay? Alright, so what we're going to do is kind of take some points on this graph, some y values, and flip them. Find the reciprocal, right? What function is the reciprocal of cosine? The reciprocal of cosine is secant. So I'm going to take these y values and find their reciprocals, graph those new y values, and see if we can kind of start to see what the graph of secant is going to look like, okay? All right, so let's plot some values. Let's take a look here. So I've got this point, this y value of 1. When I take the reciprocal of 1, I still have 1, right? So I'm going to have that point on the graph of secant as well as I do for cosine, all right? Okay, let's keep going along. We're going to graph basically from 0 to pi, plot some points, see what we think. Okay, so my next point, look at this y value of 4/5. When I graph its reciprocal for that same x value, I get 5/4, right? So a little bit above 1. All right, let's keep going. Here's my y value of 3/5 on the original. Plotting that reciprocal, I would get 5/3. Okay, let's keep going. Okay, here's a y value of 2/5. Plotting its reciprocal now is 5/2 or 2.5, okay? And another one here. Here's a y value of 1/5. Flipping that, I get a y value of 5, right? Okay, so you can see I'm taking these y values. I just happen to use subsets of 1/5. I'm moving over by 1/5 each time. So can you tell where my next y value is going to be on the red graph? It'll be at 0. However, when I flip 0 and I take the reciprocal of that, it's undefined, right? So I have no y value for the purple graph there, okay? All right, let's keep going. If I go down by 1/5 again, I'll be at -1/5. So if I flip -1/5, now I have -5. Then I've got -2/5. Let me take the labels off so you can see this a little better. Okay, and then I'm going to have -3/5. So you can see when I flip that, I have -5/3. And you can see as we get closer and closer to 1 and -1, here's y equals -1. When I flip that, the reciprocal is still -1. All right, and we could keep going kind of with this method. Let's connect some of these dots. Let's get a good picture of the graph of y equals secant x. So here we are. Okay, so you can see once we've got the graph of cosine of x, the graph of its reciprocal, secant of x, kind of falls straight from that. You can see wherever we had a local maximum, we now have a local min, and vice versa. Where the red graph has a local min, now the purple graph has a local max. Okay, notice that as the red graph approaches 0 positively, the purple graph is going to get bigger and bigger positively, so it's going to approach positive infinity. as the red graph approached 0, but from the negative side, so we had all negative values here. So if I come to the left here approaching 0, my y values were getting smaller and smaller, right? But negatively. So now you can think of it, your y values, the magnitude is getting larger and larger, but negatively. So wherever we had zeros for the red graph, we now have what for the purple graph? We now have vertical asymptotes, all right? Because again, when I take 0 and I find the reciprocal, it's now undefined. All right, so I have cosine and secant graphed together here again, and I just want to show you that your transformations apply, okay? So I can change my A value, my B value, C, and D, and you can tell that those graphs just stay connected. And not surprisingly, the same is true for sine and its reciprocal, which is cosecant, okay? So if I want to graph cosecant of x or any transformation, first graph sine, and then go ahead and plot sort of these peaks and valleys. One thing I do want to make sure we're mindful of is these are not parabolas, right? Because they do not go to the left and the right forever because we have these vertical asymptotes, okay? So let's not use that term parabolas for each part of secant and cosecant. All right, let's try example 1 together. I've got y equals -2, secant of x plus 1. I'm first going to graph the reciprocal function. So what's the reciprocal of secant of x? The reciprocal is cosine x with the same transformation. So I'm first going to graph y equals -2 cosine of x plus 1. Okay, so cosine of x starts at 0, what? 0, 1. So for the parent function, let's always plot those first 5 points first. So I go 1, 0, -1, 0, 1. So we're going to start with those 5. Now let's transform. All right, so for outside functions, it looks like I would multiply by -2 first, and then add 1 if I'm thinking about PEMDAS, right? Okay, so if I multiply by -2, this y value becomes -2. 0 stays 0. This y value is -1 times -2 becomes +2. 0 remains, and then this y value of +1 changes to -2. So you can see that we have stretched by 2 and we've also reflected, correct, about the x-axis, which is a vertical transformation. All right, and then finally I'm going to shift up 1, so we should be right about there. All right, so if I'm graphing this function, remember concave up, concave down, and then concave up. All right, so now if I want to graph this function, take a look at where your zeros were before the shift. Here, so that's where your asymptotes are going to be, and here. And now wherever you had a max, you're now going to have a min. Just follow those asymptotes. And wherever you had a min, you're going to have a max, and we have just one period. Of course, this pattern would continue on both from the left and the right, but that's one period of this function. So here's example 2. We've got y equals cosecant of x over 2 plus pi. So first think about what is the reciprocal of cosecant. Reciprocal of cosecant is sine, so I'm going to take sine of those same transformations, so x over 2 plus pi. Okay, and with inside transformations, we do need to be pretty careful when I have more than one as to what order we go about doing this. And remember, inside's always opposite. So again, we're thinking, okay, what do I need to do to get x by itself? That's why inside's opposite, because y is already by itself. So our y, our vertical transformations, they function exactly like we would think they would function, but inside we don't have x by itself yet, right? So if I wanted to get x by itself from the inside there, I would subtract by pi first. So I'm first going to shift left by pi units, and then I would multiply by 2. Okay, so that's exactly what we're going to do to our x values. So let's first plot our 5 original points, and our first point for sine is what? It's the origin, 0, 0. So I'm going to go y equals 0, up to 1, 0, -1, back to 0, and there's 1 period. Okay, so now my transformations, we said we're first going to do what? We're first going to shift to the left pi unit, so that would take me about there. And what's the second thing I want to do with the x values? Second thing we're going to do is multiply each x by 2. Remember, what would I need to do to get rid of that? Okay, so if I take x equals -pi and multiply by 2, I'd now be at -2 pi. This x value is currently -pi over 2. Multiplying that by 2 takes me to -pi. This x value is 0, so if I multiply that by 2, I still get 0. This x value was pi over 2, so multiplying by 2, I get pi. This x value was pi, multiply by 2, I get 2 pi. Okay, so that sine function looks like this. Remember, concave down, then switch to concave up. Okay, so now if I want to graph the cosecant function, take a look at where your zeros are, because I did not shift up or down. That's where your asymptotes are going to be. And then wherever you had a max, you're now going to have a min, and just kind of follow those asymptotes. Oh, Penny's here. Say hi, Penny. And wherever you had a min, you're now going to have a relative or a local max. So follow the asymptotes. Okay, and that's that. All right. Here's example 3. I'd like for you to try this one on your own and bring it to class, and we will discuss. Remember to first graph which function? We're first going to graph cosine in this case, and then transform it to negative cosine of 2x minus 1, and then you can go ahead and do the function that is on the screen. All right? Okay, I will see you all next time.